Good morning. Today we're going to complete pages 19 through 21. We're going to look at characteristics or graphical behaviors. Our goal is to see if there's similarities or differences that you can point out. So on page 19, it says that Matthew grouped these graphs together. Why do you think he put these graphs in the same group? And there's lots of different reasons. So Matthew's reason might be different than your reason. So looking at those four graphs, why do you think he put those together? What could possibly be similar? So I notice all four of these graphs are made up of individual points. So please do not say dots. They are individual points, and you can see the points because they are not connected. So Matthew grouped these graphs together because the points are not connected. I'll wait till you guys have all of that. Later we'll find out a vocab word that means graphs that have points that are not connected. Some of you might already know it, but we'll hold off for another day or two. When you're ready, go ahead and flip the page. So now we're on page 20. Okay, Ashley says, I grouped these graphs together because they all have a vertical line of symmetry. If I draw a vertical line through the middle of the graph, the image is the same on both sides. This thumbs up means that Ashley is correct, but we are going to prove that she is correct. So we might have to remember which way vertical is. Vertical is up and down, right? So if she drew a vertical line, then the graph would be symmetric or have symmetry. So symmetry means, let me write it on this side, it's balance, or it's the same on both sides. Like if you think of shapes, a heart has vertical symmetry, a star has vertical symmetry, a circle has actually vertical and horizontal symmetry. What other shapes? A square, a regular trapezoid, so trapezoid that has the slant sides are the same. Okay, so symmetry means they're the same on both sides. Ashley's saying there's vertical symmetry. So if she folded these graphs in half, up and down, then they would match up. So for this first graph, I'm actually going to pull out a highlighter or a colored pen. We're going to highlight where the vertical symmetry is. So we're going to show where there's vertical symmetry. We're going to show why her reasoning is correct. So for this first one, I'm going to highlight the y-axis. Right? So if I folded along the y-axis, this graph would match up. How about this one on the top right? Where should we highlight? This one I could also highlight the y-axis. And then moving down below, on the bottom left, what can I highlight? Ooh, also the y-axis, right? This U shape, if you fold along the y-axis, there would be symmetry. Both sides would match up. They mirror each other. What about this fourth one? Should I highlight the y-axis, right? If I highlight here, there's not going to be symmetry. So there's symmetry right here. And actually, bonus question, do you know how to write the equation of the lines of symmetry here? So for this one, let's see, the graph is going by twos, right? 0, 2, 4, 6, 8, 10. So this is -2 on the x-axis. So this yellow line, the equation of that would be x equals -2. Bonus question. So if you don't get that, it's okay for now. These other three should all have the same equation for the line of symmetry because they're all the y-axis. And the y-axis goes through 0 on the x-axis. Like this went through -2 on the x-axis. So the equation of the y-axis is x equals 0. That's because the y-axis goes through 0 on the x-axis. We'll revisit that a little while later, but just as a bonus question. Okay, down here, if possible, you're going to show other graphs that have vertical symmetry. So there's a bunch of graphs starting on, let's see, page 23 through 27. I'm going to write that down. Eventually, we're going to cut them out. Please do not cut them out today. It's a lot of graphs, and it's going to be a giant mess. So I'm going to pull out my graphs, I think. Do I have them? Oh, I didn't cut them out. That's okay. Okay, so looking at your graphs, you're going to go through and write all the ones that have vertical symmetry. So go ahead and pause for now. Go through and just write down the letter of each graph that has vertical symmetry. So go ahead and hit pause. Okay, the graphs that have vertical symmetry, I noticed were B. Right, B was that kind of, I'm going to sketch what it looks like. B was that upside down U shape. That one had vertical symmetry. What other ones? D does, because what's the shape of graph D? It was that circle. And what else? H also has vertical symmetry. It's that upside down V shape. And J does, but I think we already used those graphs. So we're trying to find other graphs. So if it's of the 4 up here, we're not going to write them down here. Because this one, I think, was graph C, right? This one's graph C. This one's graph E. I'm just going to write down the ones we've already used. This one is J, I believe. And okay, this one is Q. So we're looking for other ones besides C, E, J, Q. I left off on B, D, H. Okay, after H, I notice, K. K is this U shape, but it's sideways. That one doesn't have vertical symmetry. It has horizontal symmetry, but we're just looking for vertical, so not K. What about graph N? Right, N is also a V-shaped graph, pointing down. Okay, I think that was it. Just B, D, H, and oh, maybe I left one out. Sorry, I didn't flip one more page. Ooh, this one's kind of an odd one. So graph R, because even though it's all these individual points, right, you could draw a vertical line somewhere and there would be the same amount of points on each side. So B, D, H, and R. Okay, I'm going to flip to page 21 now. Judy grouped these graphs together, but she didn't provide any rationale, so she didn't provide any reasoning. So discuss with someone next to you or see if you can figure out why these three were not grouped, didn't have a reason as to why she grouped them together. You might want to think back to accelerated seventh. when you talked about functions and non-functions. Okay, for these three graphs, maybe something I noticed is that these three graphs have horizontal symmetry, right? We just did vertical symmetry. Horizontal symmetry is across. So you could cut this circle in half here. You could cut it over here along the x-axis, and then this line you could cut in half that way. So I noticed that they have horizontal symmetry, and I'm hoping that you remember from last year that these graphs are not functions. And that is because each value of x has more than one value for y. So wait till you write that down. Okay, so each value of x has more than one value for y. So what I mean is if I look over at this circle, the circle graph, right? This x coordinate is 2, but it has a y coordinate right here, whatever it is, and also right here. So this x coordinate has more than one y coordinate that goes with it. Same over here. If I pick maybe right here, 2, 4, 6, this is 6, right? The x coordinate would be 6 and positive something, and 6 and negative something for the y coordinate. So there's 2 y coordinates that have the same x coordinate. And then this one, graph O, all of these points, right? This point right here would be 2, 0. This one would be 2, 2, 2, 4, right? 2, 6, 2, 8. And then if I go down here, this is 2, negative 2, 2, negative 4, 2, negative 6, 2, negative 8, and it would continue. So all the x's are 2, but it has more than one value for y. So those are not functions. And we'll talk about later, when we introduce a lot of vocabulary, what test you can use to determine if a graph is not a function. All right, your homework today, remember we pushed it off from yesterday. It's the same pages as the other day, but it's different problems. It's your page 16, number 2, and page 61, number 3 through 4. Again, if you have very nice handwriting, you can use those textbook pages to show your work and your answer. But if you know that it's going to be a mess, please use a separate piece of paper and make sure you do answer checker number 2 that goes with it. Okay, have a good day.